going to start all over. Oh well. For the third time. For the first time in forever. Oh no, I promise not to sing. Because I'm not musical at all. Alright, so here we go. I'll keep my feet to myself. So did we get a resolution to this thing in green here? So if oops. So what do we think? Is it okay if we say epsilon must be in first of C? Now, how can epsilon ever get into a... You don't see a picture. Who doesn't see a picture? And what picture are we talking about? The screen? Okay, so Louis says, not working without C going to epsilon. That's not entirely true, but it's close to being right. It definitely is true if we have, if I have C goes to epsilon, will ensure it. But C goes to x1, x2, dot, 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 xn, where xi is a non-terminal, and epsilon is in the first of xi for all I. That would also guarantee it, right? And now we're sort of closing a loop now, because that's exactly the question I asked about, right? So I said, let's see, Louis said this would work. And that's definitely true. If there's one of the branches here that is an epsilon, then we get an epsilon, no doubt. But you could also have a branch that consists of just non-terminals, and each of non-terminals has epsilon in their first set. Therefore, we have epsilon in that entire first set, which is basically what we have, what we're coming to here in the mixed string situation, and what we have here, because we have a right-hand side here that consists of just terminals. Sorry, just non-terminals, and I'm basically asking, when do I get epsilon in the first set of a string of just non-terminals? And that is when the terminals individually have epsilon in their first sets. So let's just try the following. Let's say here now, I should do that in red. If epsilon is not in the first of y1. So this very first guy here cannot derive epsilon. Then surely the first of y1 dot 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 yn is just the first set of y1. Is there anybody who's not happy with that? So think about it this way. If y1 cannot produce an epsilon, and if I always, when I compute first sets, just look at the very first terminal, then that very first terminal will always come from y1, because it never disappears, which means that we don't have to worry about any of this other stuff that's behind it. So I get this equality. But now what happens if epsilon is in the first of y1? Well, the first of y1, y2 dot 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 yn is now equal to, well, we definitely need those terminals from first of y, but we have to take the epsilon out, because I don't know that I can. Let's see, Benjamin says, so is it not fully correct to say C goes to epsilon, but it would be true that C, first of C must include epsilon? Yes, I prefer the latter, because that is the complete answer. The first one is an option that would satisfy the second part, but the second part is the correct way to say it, because that also encompasses this situation there. So if Where were we? So we're going to have to draw out the epsilon here, because I don't know that this entire thing has an epsilon in it, because it only has an epsilon in it if every single one of them, oops, can turn into epsilon, and we don't know that yet. So it's equal to that, but we need to add a little bit more. We also need to add the first of y2 dot 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 yn. Now we can play the same role over and over and over. So for y1, y2 dot 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 yn, we can definitely say that the first of y1 without epsilon is a subset of the first of y1 dot 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 yn. And then we can say if epsilon is in the first of y1, then first of y2, we'll take any epsilon that might be there out, is in the first of y1 dot 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 yn. And we can see that because if this is true, then if I start with y1, y2 dot 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 yn, and I take a number of steps, and I use the fact that y1 can become epsilon, I end up with that. And clearly we now have to consider what set of terminals y2 can produce, because it is possible that the string generated from y1, y2 dot 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 yn reduces to simply being y2 dot 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 yn, because y1 produced epsilon. So along the line of this, y1 disappears. So now it's just rinse and repeat. If epsilon is in the first of y2, then the first of y3 minus epsilon is in that first set, etc., etc., etc. If yn, if epsilon is in the first of yn, then epsilon is in the first of all of it. So only if I have epsilon in y1, y2, y3, y4, etc., 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 and yn do I get epsilon in the very last one. So we got to be careful when we have this situation here. If there's no way that any of this stuff here can become epsilon, either because it is an epsilon, or it can derive an epsilon because epsilon is in the first of that left-hand side, then this here should not have an epsilon in its first set. I can't remember if I said this, but let's just repeat it. So for a rule, if I want to compute the first set of A, that's just the union of the first set of all the right-hand sides. So let's try one. Let's do example 4.3. So we have this A, B, E, epsilon, B, B, C, B, D, epsilon. Right, so, where do we start? Well, we got to deal with each of the of these bits here. So let's just do those. So if I say x, first of x, and I do that. So if I have A, well, that's the terminal. We know that the first of a terminal is just a terminal. If I have B, E, We'll come back to that one. Epsilon is just epsilon. Little b is just b, c, b, d. Well, here we can use this rule, right? So we say, right, we grab the first set of the first guy, and then we continue on if there's an epsilon in that first set. All right, so first of C, well, there's no epsilon in there, so that's the answer. And oh, it's another epsilon. Get that. And then I'm going to put a B here now, because I know that B is just the union of those. So that gives me that. So that's just B, C, epsilon. Now this guy over here, so first of BE is, well, it contains the first of B minus epsilon, which is BC. But epsilon is in the first of B, so first of E minus epsilon is also a part of first of BE. So therefore, well, first of E is just E. So therefore, first of BE must be BC and E. BC, E. And if we look at that, that makes sense, because if I'm deriving something that comes from here, then I can either replace that B with that B, so now it starts with a B. I can replace it by CBD, now we start with a C, or I can let it disappear on an epsilon, then we start with an E. Keine Hexerei, nur Behendigkeit, as they say in Germany, right? Let's see. So let's just consider something slightly different, unless there are any questions to that. So we have a grammar like that, and I'm going to tell you something else. I'm going to tell you that the first of B is I wanted AB, and the first of C is CF. Right. So if I have and if I have a derivation that starts like this, if I don't tell you anything else than what I've told you here, and I ask you the question, is it possible always to make the right next step in this particular situation, no matter what the input is? I never having to backtrack because I got something wrong. With a look ahead, otherwise you're stumbling in the dark. Trying to do any kind of parsing without a look ahead it becomes really, really, really hard. I don't think you can do linear parsing without a look ahead, because it does require a certain amount of leaps of faith. Well, when we get to the LR0, that is that is no look ahead, right? Yeah. But it's also non-deterministically, so there's no guarantee you can do it in linear time. All right, so while we were talking amongst ourselves, yes, because it passes the pairwise disjoint test, which we haven't talked about. And Daniel says, yes, the first step is non-ambiguous. And Ryan says, yes, because all of the firsts are different. Ooh, Ryan, be very, very careful. I feel like I'm a fun. Right? Be very, very careful. yes. For hunting disjoint sets. So if I look at the following, so be careful, because if I say A goes to B, C, D, and B goes to something, C goes to something, D goes to something, and I say first of A is AB, first of B is BC, and first of D is CA. Those first sets are different. But what I claim, or what you claim, is true for the blue example, that you can always, no matter what you see on the input, make this first step correctly without ever having to go back. Can you do that for the red as well? No, you cannot, right? But those sets are different. So what's the problem? Give me an example of what could go wrong for the red one, maybe. So if we're trying to do I don't know, A goes to something. So let's say what do you want? What do you want? You want the if your look ahead shows an A, then you don't know if you have to go to A or D. That is right. Yes, indeed. So that's the problem, right? If I see, what did you say now? I forgot again. An A. Right. So if I see on the input an A and I have to produce a right hand side here, B, C, or D, that can produce input that starts with an A. Then I know first of, oh, let me just fix this. That should not say first of A, B, and D. That should say first of B, C, and D. Right. So if I know that I need something that starts with an A, well, that could have come from there, and it could have come from there. Now, why do I not have a problem like that here? And why is, so now we can see why down here it's a problem, if even if the first sets are different. So in the blue there's no overlap of terminals, unlike in the red. That's correct. Yes, so there's exactly no overlap. And when you say no overlap, that means if I want to figure out if I have an overlap, how do I do that? So if I want to figure out if there's any kind of overlap, so let's see, Daniel says, the sets of first must not only be different, but they must be pairwise disjoint as well, right? So if I were to look at, let's say, these two together, they can't have anything in common, right? Because if they did, then they had some overlap. And these two guys can't have anything in common, and these two guys can't have anything in common. So what I can do is I can just compute intersections of all possible combination of pairs. So I look at this one and this one, this one and this one, and this one and this one, and then they can't have anything in common when I do that. I mean, there are a number of different ways you could do it. You could do it by unioning and counting and something like that. But the pairwise disjoint test, where we say, all right, we're going to look at the intersection of first sets between all possible pairs of the same right hand side, right? So when I do this, when I do these checks, I have to do it between pairs that are on the same side, or that are on the right hand side of the same non-terminal. This is sort of this stupid mistake that some people make, where they say, oh, I'm going to look at all possible combinations of all right-hand sides, which of course is nonsense, because what is it that I'm trying to do here? Well, I'm trying to figure out, right, what's the next step here? What am I going to replace A by? But I never replace A by anything other than a B or a C, right? So if there's a rule for X goes to something here, none of these right-hand sides here will ever come and play here, because I only have those two options. So what we can say here is, because A and B intersected with C and F is the empty set, we can always look ahead one and make the right decision. Right? All right. Well, that's good. So would it be acceptable to say that a necessary condition that has to be imposed on any grammar in order for it to be LL1, i.e. something that we can parse or we can mimic the correct leftmost derivation on, for, with, for that to be possible, this sort of thing here has to be true between all the right hand sides of this one, all the right hand sides of this one, all the right hand sides of this one. Because if they don't intersect non-empty, so if any of those intersect non-empty, which they all happen to do, I can't always, or I can't make it a correct choice. So if I see, well, what do these have in common? They have a B in common. So if I'm trying to parse an A and I see a B, then it could have come from B or C, right? So if any of these intersections are non-empty, then the grammar cannot be LL1, because if whatever is in that intersection came up on the input when I was trying to parse the left-hand side, then we'd be in trouble. So I'm going to write this in purple. Just actually, maybe we should do it in pink. Yeah, there you go. That way you won't forget. So a necessary condition for the following context-free grammar, and now I'm going to just give you one here. A1 goes to alpha 1 1 dot 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 alpha 1 n1 dot 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 am alpha m1 dot 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 alpha m nm to be LL1 is. Right, so how do we translate pairwise comparison or pairwise disjointness to an entire grammar and an abstract one like this? Well, we start by saying, okay, for any left-hand side, for all the possible right-hand sides here, if I look at those pairs, then they have to be disjoint. So we'll say, pick a left-hand side. All right. For all I, where I is between 1 and m. Okay, so this says for all left-hand sides. Right, so now what we have to do is we have to say that given a left-hand side, or having picked the left-hand side, we can now say, right, for any two possible different right-hand sides of this particular left-hand side, this pairwise disjoint has to be working. So let's pick j and k, where of course j should not be equal to k, and it should be within range. So now I've picked two right-hand sides. So this says for all possible pairs of AI, actually all possible, write that out, right-hand side pairs, And so this is basically picking the AI, and those right-hand side pairs are AI, J. Oops. And alpha, I, K. All right, back to pink. The first set of alpha, I, J intersected with the first set of alpha, I, K is empty. So there we go. I don't know how many times I've written that in my life. And in the good old days, when you can see people's faces, they would always go like, "Huh?" Because most people aren't. In reality, you haven't taken enough math. You should have taken more math, right? Because math is good for you. Why are you laughing? That's what you always say, right?
But I've never really heard it that way.
Oh,
more math is good for you.
So your mother never said that to you? No, really? I'm surprised. I thought she would have.
Well, she never needed to.
Oh, goody two shoes, right? So people get scared from this, but oh my god, if you think this is scary, you should try to take real analysis. You know, you've got epsilon balls, and yeah, you know, that stuff is hard. This is child's play, right? And it's very precise, right? Because it tells you exactly what's going on here. It says for every left-hand side, and when I say for every left-hand side, it means if I pick a left-hand side, AI, then for all possible combinations of JK that are within the range of what's possible for whatever left-hand side I picked, where they're not the same, then for every left-hand side, if I pick two right-hand sides of that left-hand side that aren't the same, their first sets must intersect. Empty. And that's exactly what Daniel and Benjamin and Brian and Dennis and everybody said, that that had to be the case for us to always be able to, with just one look ahead, determine what's the next step in the derivation. So, is it possible, if I have a grammar that satisfies this, that it is not LL1? Well, obviously the answer to this must be yes, because I put necessary here. But not sufficient. So it is possible that there are some grammars that are LL1. That it is possible that there are some grammars that satisfies this, but they're still not LL1. But all LL1 grammars do satisfy this. So let me just actually write that down. So all LL1 grammars satisfy this, but not all grammars satisfy this are LL1. Anybody want to take a guess at what it is that that causes that? I mean, it's an unfair question. But if you've sort of paid attention up until now, you probably have a reasonably good idea of what the problem child is here. You know, who is it that causes trouble? No, nobody? Gremlins? Well, Oswaldo for sure. And then Gremlin could be a correct answer for that as well, I guess. He's so tired these days that he's no fun in fighting with because he just rolls over and gives up. That's what happens when you have a small child. Plus, he'll be constantly sniffling for the next 17 years. Um, so, no, it is neither Gremlins nor the other band. Actually, Oswaldo is the name of the processed J elephant. Just so you know, I know that raises a lot more questions than it answers, but nevertheless, huh? Say what? So it's the epsilons, right? It's the damn epsilons. And it turns out that if I have any of these right hand sides that have an epsilon in their first sets, then if there is any of these guys that have something in their first set that is also in something called the follow set of their left hand side, then we run into trouble, and that makes it not LL1. But we'll get to that next week or something. So now let's see how the shape of a grammar can affect its ability to be LL1, and let's see if we can do something about it. Or if it had been Canada, we'd do something about it. We used to say in the old days. So let's go to 4.3. Which is grammar transformation. So we'll start with 4.3.1, left recursion. And let's just start with an example. A goes to A alpha or little b. So is that LL1? Well, we don't know, but we can definitely say that if it fails the intersecting first set test, then it's definitely not LL1. So let's give it a go. What's the first of A alpha? What's the first of B? And just for fun, I'll ask what's the first of A, because I know it's just the first of A alpha union first of B. And this one here is easy. So I shall do that one. We get a B there. This one here becomes just a B. And now we're stuck. So let's see what... Can anything self-referential like this be LL1? I don't know. Can it? That's a good question. So no, it cannot. What if you have A goes to A alpha or epsilon, and then whatever is in the first of alpha is not in the follow set of A. That is LL1. I think it is. And if you remind me, we'll look at that when we get to it. So, but in this situation, let's see what Dennis says. Isn't the first of A alpha equal to B because it never stops going back to A? Well, yes and no. Yes, you're right, but we just need to adjust your we just need to adjust the statement ever so slightly, because never stops is not true, right? Because if you say never stop, then that in some way, until it hits the B, that's right. It never stops until it hits the B, because it's important that we're dealing with finitely long, we need strings that have a finite length. We can't have infinitely long strings, because that would mean that you would write infinitely long programs, which takes such an awful long time. You'll never meet the deadline, right? So if I look at this and we do a derivation, let's not use let's use this one here. So A goes to A alpha, goes to A alpha alpha, goes to dot 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 goes to A alpha n goes to B alpha n, right? So there are only two options. You can either stop the recursion by taking the B, or you can continue. And if you continue, you're just piling more alphas at the end, right? So if I look at this and I say, okay, what's the first set of that? Well, what's the first set of that? A B. So yes, you're right. So the first set of that is a B. And those intersect not empty, therefore not LL1. Right, so we can say here in powerful red, left recursion implies not LL1. So the question is, could I twiddle the grammar a bit, tweak it, change it, do something to it, so that it becomes LL1, but at the same time still produces the same language? So can we change the grammar to be LL1 and still produce B alpha n? Question mark. Will right recursion work instead? I don't know. Let's give it a go. So right recursion, we can do alphas in right reversion, right? So if I say A goes to, we got to start with a B, then we'll have an A prime, and A prime will be, and now I should not feel tempted to do A alpha or epsilon. I should do alpha A or epsilon, right? So now I've thrown in some right recursion instead. So we've got right recursion there, right? So we always start with a B, that's this guy, oops. That's that one, and then we go and do as many alphas as we want, but we do it in a right recursive manner. So let's see. What's the first set of, well, there's only one right-hand side there, so that can't go wrong. The question is this LL1 now? Well, if I look at this, then the first set of alpha A is just alpha, and that's an epsilon. They have nothing in common, and we're good to go. So that is, yep, no problems. So can we maybe try? Can we try to generalize this a little bit, because we did this, and then if we say in general, if A goes to alpha 0, so the A we recurred on, I think it was A alpha 0 dot 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 A alpha n or beta 1 dot 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 or beta m. Could have used B there, but whatever. And oh, should we do that as a 0 as well then? So can I rewrite that in such a way, because now I have, look, there's a whole bunch of right recursion there. So alpha represents some mixed string. Yeah, sure. And so does beta. Let's just assume that none of the first things in beta is an A. So we can definitely say, let me write that down. Alpha I is any string or sentential form. And beta I is any string or sentential form that does not start with A, because if it did, then it would be an alpha, A alpha something, right? So what if we just keep it at alphas and betas rather than trying to think of them as something else, because it doesn't really matter what they are, but it makes sense to sort of think of them as pseudo terminals here, right? Because at some point they're going to contain a string when they get expanded. So any string derived from A starts with what? So if I say a string derived from A starts with what? Well, if I look here, we could see eventually it has to become a B. So what here? I can recurse on this for as long as I want, but eventually it has to become one of these, right? So the answer here is some beta I. Okay, well now we're in business, right? Because now we can just pretend. What if I did this? And we just called that beta, right? So then we can say a string derived from A starts with beta. And what is beta? That's just a choice between beta 1, beta 2, beta 0, beta 3, etc., right? But this stuff here, we could rewrite as this. And then just call that alpha. So basically now we have A, alpha, or beta. Well, we know how to deal with that because we have that recipe right here, right? So we just plug in. So it must be something we can rewrite as follows. So let me write it down. A goes to A alpha 0 dot 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 A alpha n beta 0 dot 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 beta m is equivalent to, I'll lift that alpha out, and then we'll just pretend this is alpha and this is beta. So that must be equivalent to A goes to beta 0 dot 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 beta m, because that's what we had from here. Started with the B, that was that guy, that's this beta thing, and then we need an A prime, and A prime is, well, it's just the alpha guys followed by an A prime or epsilon, which of course is equivalent to A goes to beta 0 A prime or dot 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 beta m A prime. A prime is alpha 0 A prime dot 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 alpha n A prime or epsilon. So that's the general rewriting. Now let's try that with an example. If I can get to the next page. So if I have E goes to E plus B or B, right, then we can sort of try to identify what we have. If we identify that as A, that becomes A, that becomes alpha, and that becomes beta. And we know that A goes to A alpha or beta is equivalent to A goes to beta A prime. A prime is alpha A prime or epsilon. Right, so then we just got to do this, where A is E, B, so beta is B, A prime is E prime, A prime is E prime, alpha is plus B, etc., etc. So we get E goes to, well, we need the beta, that's the B, and then we need E prime goes to, then we need the alpha, that's plus B, E prime, or epsilon. There we go. Now there could be some problems with indirect left recursion, and there is a solution to eliminating that on page 120 to 121. So take a quick look at that. I'm not going to ask you to do that because it's a bit of a pain in the butt. But I will, and I give you fair warning now, I will ask you to do this on the final. Just eliminate left recursion on something. So it's easy points because all you have to remember is this general formula, and then you identify what's what, and then you plug it in. There is nothing complicated in this. They're 3 points. Like most of the points in the final really are 3 points, right?
Almost half.
Almost half, right? So if you fail the final, you really didn't pay much attention. Yeah. There's really no point in failing this course unless you are sitting around with your head up your butt or something, or wherever it is you can stick your head. Right. 517, which means that we should be done. I wanted to tell you about common sub-expressions, but I guess that'll have to wait till another day. So go knock yourself out with a video for phase 2 once you've read chapter 5. How many points will this question be?
At least 1.
How the hell would I know? But Ben says at least 1. That is good thinking. Yeah. So I guess that's it. Bye for now.